Hello, it's Dr. Bhatt from Chem. Today, we have picked up a topic from organic chemistry regarding aldol condensation. Of course, we already had a video relating to aldol condensation, and we got a general idea about what is aldol condensation and what are the conditions of aldol condensation, etc. So, I request our viewers and learners to please go through my earlier video regarding aldol condensation. But still, the topic today is specifically related to what is known as cross aldol condensation. Now, what is this cross aldol condensation and what are the conditions of cross aldol condensation and what are the products of the cross aldol condensation of different uh, compounds containing CO group, that is the carbonyl group. We shall go through it because we find that many of our students did not find the correct number of products obtained by cross-aldol condensation of different aldehydes and ketones. So, it's here. Let us go through what is meant by cross-aldol condensation. Cross-aldol condensation or mixed aldol condensation is the condensation occurring between carbonyl containing compounds such as aldehyde and ketones which have different molecular structure. That is very important. Of course, the conditions are same as usual in all conditions, other aldol condensations. Now let us go through a molecule of ethanol and propanol. These are two different molecules. They undergo condensation, and the condensation which would occur between them would be of two types. Firstly, there can be a condensation of ethanol and propanol using alpha hydrogen of ethanol, because we find that in both the compounds, whether it is propanol or ethanol, both of them contain alpha hydrogen. So, which alpha hydrogen will be used as a nucleophile or which alpha hydrogen will be used or attached with the oxygen of the is very important to decide the product form. Now here is case 1 is there, alpha hydrogen of propanol gets attached with oxygen of ethanol as shown here. That means oxygen here acts as a nucleophile for alpha hydrogen of the propanol. And the product, of course, the condition is same, that is in presence of dilute NaOH, you get 2-methyl-3-hydroxybutanol. Now, this product is not very stable. Here, hydroxyl ion acts as a catalyst itself, dilute NaOH. Now, in the structure, you find that H and OH in the second and third carbon atom are very close to each other, they are adjacent, and therefore under suitable conditions in presence of anhydrous HCl, a loss of water molecule sets in and a little heating may be necessary and you get an alkene. The alkene is 2-methyl-but-2-enol. Now there is another possibility of aldol formation when alpha hydrogen of ethanol gets attached with oxygen of the propanol. This is the other way. Propanol, oxygen, the carbonyl group, oxygen acts as a nucleophile and gets bonded or attached with alpha hydrogen of ethanol. You get a product here which is pentanol, 3-hydroxypentanol, and again the same way because of the closeness of H and OH between adjacent carbon atom, there is a loss of water molecule under anhydrous acidic conditions and you get pen-2-enol. Well, there can be another case where benzaldehyde and a ketone, say acetone, propanol, suffers aldol condensation. Now, if we observe here, you will find that benzaldehyde C6H5CHO does not contain any alpha hydrogen atom, but it has a carbonyl group, and ketone, of course, has a carbonyl group with two alpha hydrogen atoms on both the sides of the carbonyl group, and therefore the ketone carbon of ketone contains a hydrogen atom which is bonded or which is attached with the carbonyl oxygen atom of benzaldehyde. Of course, in presence of dilute NaOH, and you get 4-hydroxy 4-phenyl but2-one. Same way, in acidic conditions, anhydrous, no water should be there. There is a loss of water molecule, and you get 4-phenyl but3-ene-2-one. To own. So it's very simple to make out the products of aldol condensation, provided you identify which would be an nucleophile and which would be an electrophile between the two, if both the hydrogen, and you have to identify the alpha hydrogen atom or the alpha carbon atom present in the compound. So next is another case of cross aldol condensation between benzaldehyde and acetophenone. Same way, in presence of dilute NaOH and 25 degrees Celsius or 293 Kelvin, you get 1,3-diphenyl 3-hydroxypropionene, and finally on heating in presence of anhydrous HCl, you get 1,3-diphenyl prop2ene 1-one. So please go through it and try to understand, try to get what is alpha hydrogen, what is alpha carbon, and which will be acting as a nucleophile or the electrophile. Now, before we close today, it would be worthwhile to have a practice on uh, aldol condensation. And there are just 4 simple examples provided here for you to practice. A and B would be a simple condensation product, not cross aldol condensation. 2 molecules of propanol and 2 molecules of butanol in presence of dilute NaOH, what would be the product? You have to make out. Similarly, what will be the product of cross aldol condensation between these 2 molecules? You have to find out. Okay, please go through it and try to solve yourself, and we shall let you know a little later what are the products, what are the substances obtained, aldol products. Okay, you find it out here. So get the answers like this. The answer is for A, question A, which is a simple aldol condensation, is 3-hydroxy-2-methylpentanol. I suppose you must have got it. Secondly, question B, again the answer should be 3-hydroxy-2-methyl-hexanol. Question C, the answer is 3-hydroxy-2-ethylpentanol. And lastly, it is 3-hydroxy-2-methyl-hexanol. Okay, so please go through it and try to get the concepts for cross aldol condensation and making out the products of cross aldol condensation along with the simple aldol condensation which we have already taken up. Okay, thank you. We stop here. Please, we shall be back a little later with some more topics related to aldol condensation. Okay, thank you. We stop here.